Hello everybody, how are you? How are you doing? It's Murad Sultan Ezouidi again with you. I promised that today we'll make a revision for you, my kids. Okay, grade 12, and I'm here to let you be ready and for solving, let's say, diverse exercises. Okay, and these exercises are had been taken for the previous final exam. Okay, so in this, let's say, lecture or this revision, please try to prepare yourself for what will be for let's say solving questions and then understanding, let's say, how can we solve the questions. Hello, bro. How are you doing? Are you okay? I'm recording a lecture. Yes? Here? No, there is no Wi-Fi there. Yes. Thank you. So now, sorry. Okay, you will not be able to reconnect. Your stream will be stopped. No longer. Okay. So, therefore, my learners will start. This is our revision. I will just start from the beginning for those who aren't attend, let's say, who didn't attend their lecture. You can see the Samahan Bilingual School SPS Department of Math Class 12 Revision Unit 1 means trig function, then let's say differentiation, then complex number, then discrete random variable, and probability distribution probability. Okay, this is Murad Sultan Ezouidi is here to help you realizing your dreams. Here is where to answer your questions. Okay, so we start from the beginning. Those who aren't who didn't attend their lecture, it's another chance to let's say understand how can they, let's say, differentiate equation. Okay, now my learners, I will just write this. Okay, this is the first question. If y equal x to the power 5, therefore dy with respect to x is what? Okay, I will just let's say paste this here. Okay, and I will insert, let's say, an equations. Okay, I will put it somewhere. Okay, just one moment. The equation I will try to insert here. Okay, I will make insertion of equation now. Okay, so I will just write this one. Yes, y equal x to the power 5. Okay, is it where I put it here? Okay, this one. So here I will make x to the power 5. Okay, and this is y is equal to y is equal to this one. I will paste this one. I will copy this one, sorry. Okay, cat. Then I'm going to use this thing. Okay, we told that I will try to solve this question. This is my learners, y equal x to the power 5. The question is find the first derivative of x to the power 5. So therefore dy with respect to x, my learners, is equal to dy with respect to x. Okay, should be equal to, this is okay here, comma. So this one is read as dy with respect to x means small d. Okay, point with respect to x. Okay, means that you are going to differentiate your function okay with respect to the variable x. So therefore the first derivative of x to the power 5, you see the index or the power 5 will come in front of this one, means like that. I will okay, I will insert, okay, not possible to insert the shape here. So this one is equal to what, my learners? Equal to 5, then x to the power 5 minus 1. Okay, then 5, okay, x to the power, we told x to the power 5 minus 1, which is equal, my learners, 5 equal 5x to the power 4. Okay, therefore this is the last answer for this question, x to the power 4. This is the first derivative of the function x to the power 5. Okay, then I'll just maybe I will use this one, copy. Then this is, my learners, we told the answer of the question number 1. Now if you can see that the answer here, I'll just comes up. Okay, so in your opinion, what is the correct answer here? So is it x to the power 4? Of course no. It is, let's say, x to the power 5. No, it is 5x to the power 5. Of course it will be false, and the correct answer is that. Okay, the correct answer, my learners, is this one. Okay, is this one. This is the correct answer. Okay, this is the correct answer. Okay, now, or I'll just make like that. Okay, this is the first derivative of the function y equal x squared, which is equal 5x to the power 4. Now we move to the second question. We have I'm going to see Mr. Hassin to solve this question. Hassin Tabuk. Okay. Okay. So here I will. Okay. This is for the first question. I'll put it up. Okay. Now the second question, my learners, should be just a moment. Okay, second question is that, my learners. Okay, this is question number 1. I will put this up. This is question number 1. Now we move to question number 2. Question number 2, my learners, is that if, let's say, okay, I will this is okay. Question number 2 is that, my learners. Okay, question number 2, this one. Yes, I erased the first one. Okay. Okay, just a moment. Okay, I will just erase now this one. Okay, question number 2. The equation of the normal to the curve of f(x) equal x square plus 3x at x equals 0 is, okay, is y equal negative half x plus 3, or negative 1/3 x, or 1/3 x, or 2x plus 1. So here, my learners, it's easy to solve this question. I'll just make like that. This is my question. Every one of you, let's say, is now trying to solve this one. Okay, so here, my learners, I will try to solve this question. I will insert, let's say, a table. I will now paste this one. So the y, or f of x is equal to what, my learners? Is equal to x square equal to x to the power 2, x to the power 2, then plus 3x, Okay, this is my function. Now if I'm going to differentiate my function, I will write f dash of x, f dash of x. I will write it again, f dash of x. Therefore this implies that, or this will give us, okay, will give us f dash of x. This is f dash of x, okay, means the first derivative of the function is what? Is 2 times x plus 3. Is 2 times x is 2x plus 3. Okay, then now I'm going to find the gradient of the the gradient of the tangent to the equation. I'll just write now the gradient m is equal, I will write m is equal to what? Small m here, small m equal, I will just substitute x equals 0 in my equation. Okay, so it will be 2 times 0, 2 times 0 plus 3. Okay, so this one, my learners, is equal to 3. Okay, equal to 3. Therefore my learners, the gradient now is a 3. You should find the normal, the gradient of the normal. So it will be, this is, I will make 14, or okay, then therefore the gradient of the normal, this mt I will label my learners as m, the gradient of tangent I will label it as, okay, as mt, means gradient of tangent. Okay, gradient of tangent. This is m, then this is small t, means the gradient of the tangent, which is equal to small m, which is equal to 2 times 0 plus 3 is 3. Now the gradient of the normal, my learners, should be, therefore, okay, therefore the gradient of the normal, I will write here small n, okay, to distinguish between the gradient of the normal and the gradient of the tangent. This one, my learners, equal, in fact, equal to what? Equal to negative 1 over, I will just write here, equal negative 1 divided by mt. Okay, divided by mt. And let's say here the mt now, the gradient of tangent is 3, so therefore this one is equal to negative 1 divided by 3. Okay, negative 1 divided by 3. Therefore I found now, let's say, the gradient of the normal. I'm going to find the equation of the normal on the curve. Okay, therefore here there is a formula, in fact. Okay, here I will just write the two formula may will use in other questions. So equation, I will write equation of normal, in fact is y minus y1 minus y1. This is 1, then I will raise t. This is 1, y1 equal, y1 we told Mr. Murad. Okay, no problem, I will insert it again. Okay, this is, learners, is y1. Okay, equal what? Equal, learners, we told that we are looking for equation of the normal, means it will be mn, small mn. I will copy this. Okay, the gradient of the normal, sorry, no, not this. Okay, the gradient of the normal multiply by x minus x1. x minus x1. This is the formula of the equation of the normal on the curve at x1 and y1. This is x and this is Malern's 1. Then I will close my parentheses. But you know that mn in fact is equal to negative 1 over mt. I will change this by that. Okay, this one I will just copy again. Okay, this is the formula. This one equal mn we told is minus 1 divided is, okay, minus 1 divided by mt. Minus 1 divided by mt means the gradient of tangent. I will just subtract this. Okay, do it again. It will be minus 1 over mt. I will insert this one. Okay, this is mt, and this one the t. The mt means the gradient of tangent. Therefore minus 1 over mt is in fact equal to minus 1 over 3. So this one, my learners, should be equal to minus 1 over 3 multiplied by x minus x1. Okay, now I will make like that. Now just substitution. Okay, you should find the value of x and the value of y1, okay, to find this equation. Okay, sorry. Okay, now I will write down. I'll just extend this one. Okay, now I will just write here the last answer. It will be 1 minus 1 equal this. I will copy again. I want to write it down. So this one, my learners, all of this should be erased. I will just keep the last one. Okay, now what is the value of y1? You should, let's say, substitute x by 0. Why? Because here in the question you can see that at x equals 0. Okay, therefore you need to find the value of y1. So it's clear that 0 squared is 0 plus 3 times 0 is 0. Therefore this one now is 0. Okay, is 0 minus 0. Then minus third multiplied by x minus x1 in fact is also is 0. Okay, therefore this will give us, learners, will give us y equal what? Y equal negative 1 divided by 3 multiplied by x, or negative x divided by 3. I'll just take this. So this one is equal to, okay, equal to negative 1 divided by 3x. This is, my learners, the correct answer. Okay, so if you are going to see the options that are given, we have y is equal negative 1 over 2x plus 3, or negative 1/3 x, or 1/3 x, or 2x plus 3. Therefore this one is the correct answer, my learners. Okay, now we move to the next question. Here, this question, I'll just erase this one. Okay, then I'll make here enter. This is possible. Okay, and this is the solution of this question. I will put it here. Okay, I will just make it clear for you. Okay, this is, I can erase it, or okay, no need. Okay, now we move to the second question. We have, I will make enter here. Question 4, we have what? given f of x equals 3 sine of x minus sine cubed of x. The question is find f dash of x, meaning the first derivative of the function. Okay, here my learners, it's easy here to solve this question. Okay, all the learners, I want you, boys and girls, I want you to solve or to try at least by yourself till your teacher finish the explanation. Okay, and those who can't, let's say, do this question, it's better also to do it again and to think of the question. It's not difficult and it is not easy at the same time. So f of x is 3x, 3 sine of x minus sine to the power 3 of x. Therefore, f dash is equal to what, learners? I will now differentiate my original function. I will write here f dash of x is equal to what? Is equal to, you see, 3, I will write it as it is. The first derivative of sine is cosine, so it will be 3 cosine of x. Then the first derivative of sine is cosine, and the 3, this one, it comes in front of sine, so it will be this. Don't forget about the negative sign. Minus what? Minus, this is 3 times, let's say the first derivative of sine is cosine. I will write cosine of x multiply by sine to the power 2. 3 minus, let's say 3 minus 1 gives multiply by sine of 3 minus 1 is 2. I will just erase this one and write 2. Then I will write here x. You can see this one, my learners. So this is my function f dash. You can see that 3 cosine of x, okay, is a common factor between these two terms. Okay, 3 cosine of x. I will put 3 cosine of x outside the brackets. So this one will give me, I will just write this again. Okay, so this one, my learners, I'll just make enter. This one gives me what? Gives me equal 3 cosine of x. I will make with red 3 cosine of x because it's a common factor. I will write here 3. Then cosine of x multiplied by 1 minus sine square of x. Okay, sine, we told, sine square of what? Of x. Okay, then I'm going to close the parentheses. But you already know that from the first Trig identity, you know that sine square plus cosine square is always equal to 1. Therefore, this one equal 3 cosine of x multiply 3 cosine of x multiply by cosine square, okay, multiply by cosine square of x, okay, of x. Therefore, cosine square multiplied by cosine gives me 3 cosine cubed, 3 cosine to the power 3. Therefore, you can now, at least after finishing differentiating your function, you should know about the correct answer. Okay, so here to the power 3 and here is x. So what is the correct answer, my learners? Is it A, 3 sine cubed or 3 cosine cubed, or negative 3 sine square as cubed, or negative 3, this is cosine, negative 3, this is cosine, of course, cosine. Then I will erase this one. So the correct answer, my learners, is this. Okay, please make sure that when you're differentiating your equation, don't forget to use the chain rule. Okay, now, my learners, I will just continue. Okay, so this is how can you, let's say, find the first derivative of the function 3 sine x minus x square. Now we move to the next part. Okay, I will use this one again. Okay, so the second question, given that where okay, given that y equals sine x square plus 1, find dy with respect to x. So this is my equation. It will be okay, we told y equal sine x square plus 1. To differentiate this, my learners, you will just make like that. Okay, so just make dy with respect to x is equal, first of all you should differentiate your function x square plus 1. Okay, x square plus 1 should be differentiated. So the first derivative of x square is 2x. The first derivative of a constant is 0. Therefore I will write 2 times x, then 2 times x, 2x. Then the first derivative of sine is cosine, then multiply by cosine of what? Of, between parentheses, my function. Okay, plus 1. Then I will close the parentheses. This is my learn the first derivative of the function y. Okay, so this is how can you solve the question. Now for the next one, we have y equal exponential sine of x. Now the question is that I will make enter if it is possible, or I will just come here and I will start solving the question. These are boys and girls. If you are now, let's say, I know that some of you are watching the match. Okay, thanks that Argentina is winning now. Okay, but okay, but at least you should at the same time you are watching TV or watching matches, you should also think of this kind of mathematical final exam revision, because it's very useful and beneficial, okay, for you. Okay, therefore my learners, now this is my equation y equal ax sine of x. The question is find dy with respect to x. Okay, find dy with respect to x. Dy with respect to x, my learners, is that, okay, first of all I should differentiate exponential of x, okay, and then multiply by sine of x, plus I will keep ax as it is, not change. Then I should differentiate this. So the first derivative of exponential of x is in fact equal to exponential of x, not change. Okay, multiply by exponential of x, multiply by what? By sine of x, plus okay, now I will keep ax as it is, then I should differentiate sine. So I will make exponential of x multiply by what? The first derivative of sine, learners, is cosine. Okay, is cosine of x. Okay, then I can, let's say, erase this one. You can see that now both terms have an exponential. Hello Sonia, how are you doing? I'm recording the lecture, my wife. Okay, so we told that I will put exponential of x as a common factor. Exponential of x as a common factor. It remains only here sine x, okay, plus cosine x, okay, plus cosine x. Therefore I will write them here. It will be sine x plus cosine x. Then I close the parentheses. This is the first derivative of the function. Okay, I wish that this is clear for you, my learners. Okay, and I wish that all of you are now, let's say, familiar with these questions. Okay, now we move to the next part. We have what for sub question. I will see if we have a sub question. Okay, now prove that the second or the second derivative of the function y with respect to the second derivative of the x is 2dy with respect to x minus 2y. Therefore, this is my function, okay, and I differentiated before. I will now try to use this fact. I will make like that. This is my first derivative of my function. I'm going to differentiate this again, my learners, okay, and I will see what will happen exactly. This is my function. Now I will erase all of this. Okay, I will put only the last answer. Now the second derivative of the function, my learners, is that, okay, I will write here, okay, here there is a fraction. I will make this one d second of y, okay, d second of y. This is the variable y, the function, and this is d second of x, means I will try to find the second derivative of the function with respect to x. Good boy. Okay, this is x, so I should differentiate this again. This one should be differentiated now. Okay, means that this one is equal to what, my learners? The first derivative of exponential, it will be exponential, not change. Exponential of what? Of, okay, exponential of what? Of x, multiplied by sine x cosine x. It means this one will remain the same, no change. Okay, exponential x sine x plus cosine of x plus, now I will keep, let's say, exponential of x as it is. I will never differentiate this again, but I should differentiate sine x plus cosine of x. So exponential of x, I will write, I told that as it is, not change. Okay, I will differentiate this, I will keep this as it is. I will write here exponential, then open parentheses, the first derivative of sine is cosine of x, plus the first derivative of cosine is minus, plus minus gives minus sine of x. Okay, I will close the parentheses. Therefore, this, my kids, my daughters and my sons, should be equal to that. I will just write this again here. Okay, this one is equal to, okay, equal to, this is d second with respect to x, of course, is exponential sine of x plus cosine of x plus exponential cosine of x minus sine of x. You can see this one, exponential sine of x, and here exponential multiplied by minus sine of x. This one will be cancelled, so it will be only exponential cosine of x plus exponential cosine of x gives what? Gives 2 equal 2 times exponential, 2 times exponential of x cosine exponential x cosine, okay, x, and this is cosine of x. So now I differentiate my function. I will just write this here. Okay, I will extend this one. Okay, I will make here this, I will write this again, so I'll put here, okay, where, okay, I'll put like that. Okay, I thought that's clear for you. This is 2 exponential cosine of x. Okay, Therefore, I should appear 2 times dy with respect to x. dy with respect to x, my kids, is that. Okay, is this, I mean, this is dy with respect to x. Then minus what? Minus 2y. And the function y is, you can see that, is equal to exponential sign. Okay, now I will try to add here. I will make addition. Okay, I will make addition plus 2 exponential x. Okay, 2 exponential x, 2 exponential x, then multiply by what? By sine of x. Okay, minus, as here I added 2 exponential sine of x, I should subtract the same here. Okay, I should subtract this one. Okay, now you can see this one, my learners, 2 exponential of x, this is common factor. Okay, is a common factor. Where I will use with this one, and this is also 2 exponential of x is a common factor. I will put them into parentheses. I will write 2 exponential of x between parentheses cosine, then I will erase this one. Okay, then I will come here to make parentheses minus what? Minus 2 exponential of x sine of x. Therefore, my learners, you can see that this is what, in fact, is 2 times this one exponential of x cosine x plus sine of x is dy with respect to x. Okay, I will just make up. Okay, you see this one? I will change the color to see this, the blue. Okay, you see the blue color. Okay, this one is dy with respect to x, which is exponential x sine of x plus cosine of x, or exponential of x cosine x plus sine. No difference if you are going to convert sine to cosine here. Change cosine, instead of writing sine, write cosine, instead of writing cosine, write sine. Means this is what, in fact, is 2 times the first derivative. And here, minus 2 exponential sine of x, you can see that from the beginning that your equation is exponential sine, and here there is negative 2, means minus 2y, and this is 2 multiplied by the first derivative of the function. Therefore, my learners, I will just write this as, so this one give us, this one will give us, okay, will give us what? This one will give us dy with respect to x. This is an row. Okay, a row. So this one will give us, my learners, I will make enter for this. Okay, then I will extend that. Okay, then this one, my learners, we told that I will try to reduce this, or I will make it up. I will see what can you do exactly. So I will make like that. Yes, it's okay. Then I'll put this here up. Okay, now it's clear, at least for you. Okay, now move to this one, my learners. We told that dy with respect to x is what? Is equal to times equal to dy with respect to x, this one. Okay, equal to dy with respect to x minus 2y. Therefore, I really proved this one. Okay, thank you for listening. I hope so that the lecture was clear for you. Now, if we are going to see the next question, Okay, or we will stop here. Okay, now the question, find the stationary point in the interval 0 is less than x and less than pi, and show that is a maximum point. First of all, I will use what? I will use the first derivative of the function, and I should, let's say, set my first derivative set to be 0, means I will use this one. This is the first derivative of the function, my learners. This one, yes, I will make like that. Therefore I will continue, or I will extend like that. Okay, I will extend. No need for extending. I will go down. Okay, here, yes. Now I will insert shape. Okay, and then this one is that. Okay, this is my first derivative function. This one should be equal to 0. Okay, therefore exponential of x is different to 0. Okay, exponential means that exponential of x is different, never be equal to 0. Okay, there is no real value of x such that exponential of x equal 0. Therefore I'm looking for the symbol of different, not equal, different, this one. Okay, different to 0. Then I will make sine of x plus cosine of x should be equal to 0. Okay, sorry. Okay, I will come here, I will write, therefore this one is equal to 0. This one, my learners, is in fact equal 0, means which is in fact equal to what? Also equal the square root of 2. Okay, cosine of x minus theta minus alpha, as you like. Okay, minus theta, for example. Okay, we close this parenthesis. Equal what, my learners? Equal 0, means I should solve this question. Okay, here in fact there are two methods we can use. I will make this one comes up. Okay, now we'll extend this one. Why I should set the first derivative to be equal 0? To find the stationary point. Okay, so I'll write here this one equals 0, means okay, equal 0. Okay, therefore let's say the square root, you can divide both sides by the square root of 0, it will be 0. Therefore I will write x minus theta, x okay, x minus theta here in fact is pi over 4. Okay, I will just substitute this by pi over 4. Okay, why? Simply because tangent of theta equal 1 divided by 1, or the square root of 2 divided by the square root of 2, which is equal 1, and the angle theta is tangent minus 1 of 1, which is pi over 4. Therefore theta here is pi, okay, over what? Over 4. What is pi? Yeah, Mr. Murad. Ahsant, yeah, Mr. Murad. Okay, sorry, down. Okay, now equal 0 means what? Means okay, x minus pi over 4, cosine of x minus pi over 4 is equal to 0. Okay, therefore x minus pi over 4, my learners, should be equal to pi over 2 or 3 pi over 2. This one is equal to, okay, equal to pi over 2, okay, pi divided by 2, because cosine of pi over 2 is 0, okay, or let's say x minus pi over 4 is equal to 3 pi over 4, 3 pi over 2, okay, equal 3 pi over 2, okay, this is 2 and up is 3, okay. Now we'll try to solve this one. Therefore, here x will give me what exactly? If I will add pi to both sides, okay, I will make enter. Therefore, okay, I will put this up till I finish. So x in fact is pi over 2. I will write as 2 pi over 4 to get the same denominator. X minus pi over 4 equals 6 pi over 4. I will multiply the denominator and the numerator by what? By 2 to get the same denominator. Therefore, I will transfer this one, learners, minus pi over 4 to the right hand side. It will be 7 pi over 4. I will add, it will be 7 pi over 4. And here I will add, let's say, 7 over 4 to both sides, meaning this one will be cancelled or transferred. It will be a 3 pi over 4. Okay, you can see this, the solution of my my trig function. Okay, but learners, 7 pi over 4 in fact lies between 0 and 2 pi, so that's why we are going to exclude this one. Okay, we will exclude this one. The correct answer now is that. Okay, this is the correct answer. I'll just write here. Therefore, okay, x is, okay, means x is 3 pi over 4, which is less than which is more than 0 and less than pi. This is my stationary point occurs at this, means the stationary point occurs at x equal 3 pi over 4, and you should also find y. And y equal what? Go to your function. The function, the origin function, I thought it's exponential x sine of x, exponential x sine of x, exponential x, yes, this one. Okay, therefore you are going to go back and find the value of y, the y coordinates of your stationary point. Okay, I'll just come here. Okay, go Mr. Murad. So y equal, I'll just substitute. This is 3 pi over 4. 3 pi over 4 I will take like that. I will, okay, substitution. Then sine of 3 pi over 4. This is your equation, my learners. You can use calculator to find the value of that. Okay, I will use now sine of 3 pi over 4, which should be positive. Okay, it will be, so I will erase this one. It will be sine of 3 pi over 4. Okay, which is also equal sine of 135. Okay, so 1 divided by the root of 2. Okay, so it will be positive here. It will be equal. I will try to find the value. Okay, the coordinates, I will write them again. So here sine of 3 pi over 4, my learners, you can use a calculator. It will be, I will erase all of this, it will be 1 divided by the square root of 2. Okay, I'll make a fraction here, my learners. It will be 1 over 1 divided by square root of 2, square root of 2. Okay, this is the y coordinates of the stationary point, and x is the x value of your stationary point. Now I will see if it is maximum or minimum, because the question here is what I will yes. Okay, the question, my learners, is that find the stationary point in this interval and show that is maximum. You should use what, my learners? You should use the second derivative of the function and check if it is positive or negative. If it is positive, means minimum, it's a minimum. If it is positive, if it is positive, it is minimum, and if it is negative, it's a maximum. I will use my second derivative, which we found this before here. Where is it? Where is it? Where? Yes. Okay. Go back. This one. The second derivative is this. I will use that. All of this. Then I'm going to erase something. Therefore, my learners, if I will continue, I will just write here. Therefore, to check it is minimum or maximum, you should find the value of the second derivative at this stationary point. So dy d second of the function with d second with respect to x is, I'll just substitute what x equals 3 pi over 4, which is in fact 135 degree. 135 degree if you want to convert to 2 degree. Okay, I will write here this one. I will erase this. It will be like that. Sine of 3 pi over 4, we told that. Okay, I will write as it is, no problem. Or I will use the last one. I will use the last one. Okay, the last one. Sorry, this is 2. Go back, Mr. Murad. Okay, so I'll just substitute in my second derivative the value of x, which is 2 pi over 3 pi over 4 cosine of 3 pi over 4. So keep this as it is. Now change for this one, put as it is. Okay, it will be equal. Then this is no change. Then move to what? Move to cosine of what? Of 3 pi over 4. Okay, so it will be negative 1 divided by root 2. Yes, it will be equal. Okay, mean is negative, between parentheses, negative 1 divided root of 2 minus 1. You can use, of course, your calculator. Root 2. Therefore, my learners, here you can see that this is negative, in fact. Okay, so as it is negative, we told that if it is negative means maximum. This one should be equal also. You can simplify by root 2. Okay, because this is 2, you can write as, or I will appear here, let's say 2 as, the root 2 all square. This is root 2. Okay, multiply control shift 8, multiply by root 2. Okay, give us 2 in fact. Okay, those who can see this one, I will explain it. You can cancel now. This is 2 will be cancelled, and this one is root 2 will be cancelled, so it will be negative root 2 exponential 3 pi over 4. Okay, which is negative in fact. So it's a maximum. A maximum. Thank you for listening, my learners. See you inshallah next time. I will just close this one. Okay, and now I will stop stream.